Hello class, this is a video tutorial on paying off loans. In this video we'll be looking at calculating unknown time values in a loan repayment. When taking a loan, we can calculate the time taken to pay a loan in full or any fraction of the original value by letting a of n, which is the value of the loan, equal 0 and solving for n via some logarithms. So let's get straight to it. Rather than reading this out for you, I'm just going to summarize all the key points that we need here. So we need the principal value, which is 200,000. The rate, sorry, make that capital R. The rate that we'll be using is 12% per annum, so 0.12. But because it's compounding monthly, we're dividing that by 12, so it'll be 0.01. And our monthly installment, M, is going to be 2,200. So let's first write an expression for the amount owing after n number of years. Well, we always do this by breaking up the principal as a compound interest formula. So A equals P 200,000. 1 plus R is 1.01 to the power of, well, in this case, we don't know the length of this loan. Now we move on to the annuity of the payments. So the first payment is 2,200. 1 plus R to the power of n minus 1. This continues to the second payment. 1 plus 1.01 to the power of n minus 2. Because that is 1 month less than the total length of the loan. This moves right until the second last month. It's going to equal 2,200. This will receive 1 month of interest. And the very last loan is going to be just the payment itself. Bringing these two together. Okay, so the actually, let's do just the sum of all of this first. Well, let's do that underneath. Actually, the sum of this is 2,200 plus 2,200, 1.01 plus all the way until the very last one, 2,200, 1.01 to the power of n minus 1. Factoring out 2,200, leaving us with 1 plus 1.01 plus dot 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 1.01 to the power of n minus 1. This inside here is a sum of a geometric series where the first term, A, is 1, the rate is 1.01, and in case you've forgotten, you can take that by taking a term and dividing it by the previous, and the n, here's where it gets slightly tricky, all the 1.01, there are n minus 1 of them. Because there's one more term, the number of terms there are n. So this becomes 2,200 outside of 1 times, that's A, R to the power of n. In this case, it'll be 1.01 to the power of n minus 1 over 0.01, so r minus 1, in which case it'll be 0.01 like this. Evaluating these two numbers, so 2,200 divided by 0.01, 2,000, just using a calculator now. Whoops, the calculator's not working. 2,200 divided by 0.01 is 220,000. 220,000. Simplifying this expression, 1.01 to the power of n minus 1. We're going to bring these two expressions together now. Bringing these two together, so the value of the loan at any time n is equal to the compound interest formula of this, so 200,000 times 1.01 to the power of n minus this expression here. So I'm just going to copy that to make it easy. Oh, I'm going to need some more space here. Let's do this like so. Let's actually just do this. There we go. We can further simplify this by expanding this bracket here. So this will stay the same. Oh, at any point at this time, you can skip a few steps, but I'm going to be showing you each and every one here. So expanding this one, that's 2, 2, 0, 0, 0, 0, 1.01 to the power of n, negative 220,000 times negative 1. So this will become plus 2, 2, 0, 0, 0, 0. These two are like terms. I know I wrote it differently, but you can write that as the power on the outside. So this becomes negative, so subtracting the coefficients of these, negative 20,000, 1.01 to the power of n plus 220,000, or we can just switch them around to make it look a little nicer. So and there we have an expression for the value of the loan at any time n. So now, how long will it take to pay half of the loan? Now that we have this expression, it's actually very simple to calculate the n value for this. Now, if the full loan was 200,000, half of the loan is 100,000. Now, since this is the value of the loan at any time n, we want this to be equal half of the original value. Now we just solve for n. So in this case, we subtract by 220,000, negative 20,000, negative 120,000, dividing both sides by 20,000, leaving us with 1.01 to the power of n equals 6. Solving for n, you can take the natural log of both sides, or you can just do the change of base for this. Solving for n, n equals ln of 6 over ln of 1.01, which we can solve to be 180.07 months, because remember the time frame we were working with is months. So 180.07 months. Now here's where it gets a little tricky, because whether we round up or keep it as the same, because months can be measured in 0.07, it's time, but treating this as a series where n values can only take whole integers, we will need to round up. So n is approximately 181 months, which if we want to convert to years, that's approximately 15 years. Let's do 15 times 12. What's the remaining number of months? 15 years and 1 month, approximately. Let's do this again for the full value of the loan. Once again, we're going to take the expression that we had, a of n, but this time the full value of the loan means there is nothing left at the end of the loan. Solving for n, moving this to the other side, negative 220,000, dividing both sides by negative 20,000. 1, 2, 3, 4. 1, 2, 3, 4. That's 22 over 2, which is 11. They're both negative. And solving this by change of base, ln of 11 over ln of 1.01. ln 11 ln 1.01. So this is equal to 240.986 months. This time, clearly we need to round up to the nearest whole because it's close enough, but again, because it's a series, we should only take whole values of n, although this could still be considered a valid answer because time, months, can take decimal place values. But let's approximate this up to 241 months. This one I can see 240 divided by 12. I believe that's 20 years. That's 20 years and 1 month. So I hope that gave you an insight into solving the unknown time values on loan repayments. Hope to see you in the next video. Best of luck.